Algebra 2, Chapter 13.2, Exercise 1 through 10. In this video lesson, we're going to go over half of these problems, mostly odd number problems in this set, that have to do with exponential growth functions and transformations of those functions. Describe the effect of each transformation on the parent function, graph the parent function and its transformation, then determine the domain, range, and y-intercept of each function. We have the function f of x equals 2 to the power of x, and its transformation g of x equals 2 times 2 to the power of 2x. So let's go ahead and make a table of points that we're going to put in here. So I'm going to draw a 3-column table. So here is a 3-column table. We're going to have is input values of x, output values of the original parent function f of x, and then the third column will be the transformation of that original parent function g of x. And our input values we're going to choose here are going to be x equals -3, -2, -1, 0, 1, 2, 3. And for f of x, if we put in 2 to the power of x, well, 2 to the power of -3, I'm just going to write this up here, 2 to the power of -3 is going to be equal to 1 over 2 to the third power, which is going to be 1/8. So 1/8 is going to go here as an output value. And then if we similarly put in to fx equals 2 to the power of x, 2 to the -2 power, we're going to get 1/4 as an output. If we put in 2 to the -1 power, we're going to get 1/2. And 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. And 2 to the third power is 8. And now for g of x, we have 2 times 2 to the power of x. I'm going to go ahead and put that color coded in red. So that's going to be 2 times what these f of x values are. So 1/8 times 2 is going to be 1/4. 1/4 times 2 is 1/2. 1/2 times 2 is 1. And 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And 2 times 8 is 16. So the parent function I'm going to graph first, which is going to be at an input of -3, and we have 1/8. Input of -2, we have 1/4. Input of -1, we have 1/2. At input value of 0, we have an output value of 1. And then for an input value of 1, we have an output value of 2. For an input value of 2, we have an output value of 4. And finally, for an input value of 3, we have an output value of 8. So the graph of this function is going to look like this. It's kind of hard to get these looking right. This is about as good as I can do on this thing. Okay, not too bad. And what we have here for the red one is what happens to be a vertical stretch by a factor of 2. So if we look at input value of -3, we have output value of 1/4. And then we have input value of -2, we have output value of 1/2. Input value of -1, we have an output value of 1. So about right here. Input value of 0, we have an output value of 2. Input value of 1, we have an output value of 4. For an input value of have 2, we have an output value of 8, so 2, 8 goes right here. And finally 3, 16, which is going to be way off the coordinate grid that we have. So the graph will look something like this. So initially it looks very much the same as that original, but then the graph departs from it like this. So something like this. So that'd be problem number 1. We can kind of see that vertical stretched version of the red curve there. Okay, next, problem 3. We have f of x equals 2 to the power of x, just like we had on problem 1. So I'm going to draw again a 3-column table. So we have x, f of x, and g of x. So the same input values of -3, -2, -1, 0, 1, 2, 3, and the same output values for f of x equals 2 to the power of x. We have 1/8, we have 1/4, we have 1/2, we have 1, 2, 4, 8. So graph just like we had originally. I'll draw this real quick. 1/2, 1, 1, 2, 2, 4, 3, 8. So this is what that's going to look like. Okay, that's a little bit off. Let me go ahead and try that again. It's really hard to get these right. Okay, this one is so far a little bit better. Continue to go up. Okay, so that's the graph there. And next we're going to go to the g of x, which g of x equals 2 to the power of x plus 2. What we're going to do is this plus 2 is going to be a shift. A shift in which direction? Well, this x is going to be x minus h. So what's going to happen if we have to the power of x plus 2, we're going to shift 2 units to the left. So let's just go ahead and put these in here. So if we have 2 to the x plus 2, that's going to be, if we put in -3, we get, I'm going to write this as 2 to the power of -3 plus 2 is going to be equal to 2 to the -1 power, which equals 1/2. So 1/2 is going to go right here. And if we plug in -2, we get -2 plus 2 is 0. 2 to the 0 power is 1. And so we're just shifting over here. We can just follow a pattern, multiply by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And so now I'm going to put the points in place. So we have -3 is 1/2. So it's going to look right here. -2 is 1. You put this here. -2 is going to be 1. This will be about right here. -1 is 2. So -1 is going to be 2 right here. 0 is going to be 4. 1 is going to be 8. And beyond that, we're going to be off the chart here. So I'm gonna do a little sleight of hand with this. I'm going to just use the tool available to sketch in the g of x. I'm going to go ahead and just sketch over the original f of x, okay, as tightly as I can. And then what I'm going to do is just shift over 2 units. So shift over 1, 2, right like this. And let's get that a little bit more. Yeah, something like this. Oops. There we go. So that's what that looks like. Okay, let's go on to problem. Now in this case, instead of going to the odd number problem 5, I'm going to go to the even number problem 6. And what we're doing is we're given a different parent function. The parent function in this case we're given as f of x equals 10 to the power of x. So that's going to be a different one. Let's go ahead. I'm going to do the same thing as 3-column table. So I'm going to put x and f of x and then g of x here. Now what's going to happen, because of 10 to the power of x, that's going to amplify how fast that function increases. So I'm going to use input values starting with -2 and then -1 and then 0 and 1 and 2. So we're going to have fewer points to deal with here. And let's go ahead and work that out. So if we plug in -2 for x, for f of x, we get 10 to the -2 power, which is going to be equal to 1 over 10 squared, which equals 1/100th. So 1/100th is going to go right here, and then 10 to the -1 power is going to be 1/10. 10 to the 0 power is 1. 10 to the first power is 10, and 10 squared is going to be 100. So now just sketching in the graph here, at x equals -2, we have 1/100th. At x equals -1, we have 1/10. At x equals 0, we have an output value of 1. At x equals 1, we have an output value of 10. So I hope you can see here that we have a very steep growth function here. All right, and next we're going to have g of x equals -4 times 10 to the power of x. So what we have is we can take each of these input values and multiply them by -4. So if we take 1/100th and multiply that by -4, we're going to get -4 hundredths, which is going to be simplified to be -4 over 100. I'm just working out a side problem here. Is going to be equal to -2 50ths, which equals -1/25th. So I put -1/25th. If we put in 1/10th, well, that's going to be simplified to -4/10ths or -2/5ths. If we put in 1 and multiply that by -4, we get -4. And 10 times -4 is -40. and 100 times negative 4 is going to be negative 400. So let's sketch what that looks like here. For negative 2, we get negative 1/25. For negative 1, we get negative 2/5, which is going to be about here. For 0, we have negative 4. And for 1, input of 1, we have negative 40, so way down here. So the thing is going to look something like this. It's going to be hard for me to get this right. So it goes like this. So very steep down like this. Just barely grazing that. So I hope you can see the reflection about the x-axis and the increased steepness of this red graph below that x-axis. Okay, let's go on to problem number 7. We have f of x equals 10 to the power of x and g of x equals 10 to the power of x minus 2. I'm going to come over here to the left and draw in I think I want to do the blue one here. I'm going to draw the 3-column table. Okay, we have x, f of x, and g of x. So if we put in negative 2, negative 1, 0, 1, 2, and then we put in fx, same thing as before. We have 1/100th. We have 1/10 goes here. 1, 10, 100. And then we graph this function. We get negative 2 is 1/100th. Negative 1 is 1/10th. 0 is 1. 1 is 10. And 2 is 100. So the graph will look like this. Okay, it's kind of hard to do this freehand. What is, I have a drawing tablet and I have to get my palm, it's kind of sticky, slides along it. Okay, that's not so bad. I couldn't hope to do much better than that. Okay, let's go to the g of x. We have g of x equals 10 to the power of x minus 2. So if we plug in negative 2, we're going to get 10 to the negative 2 minus 2, which will be 1 over 10 to the 4th. So that's going to be 10 to the 4th is 10 to the negative 4th is 1/10,000th. So I put 1/10,000th here. If we plug in negative 1, we get 10 to the negative 3rd power, which is going to be 1/100th. If we plug in 1, we're going to get, if we plug in 0, we get 10 to the negative 2 power, or excuse me, negative 1, that's going to be negative 3. Okay, that's going to be 1,000 there. If we plug in 0, we get 1/100th. If we plug in 1, we get 10 to the 1 minus 2, or 1/10th. And if we plug in 2, we get 10 to the 2 minus 2, which is going to be 10 to the 0 power, or 1. Finally, if we plug in 3, we get 10 to the 3 minus 2, or 10 to the 1 power, or 1. So we can put these points in here. So if we put in negative 1, we get 1/10,000th. At 0, we get 1/100th. At 1, we get 1/10th. At 2, we get 1. And at 3, we get 10, like this. So we can sketch this in. I'm going to try to do what I did earlier and sketch over this blue curve in red. Okay, again, it's sort of hard to follow with this palm that sort of doesn't slide too well on my writing pad. There we go. That's about as well as I could hope for. So we have this, and we're going to shift over 2 units to the right. So there it is. Okay, now the next instruction set we have, exercise 9 and 10, describe the graph of g of x equals to the power of x minus 3 minus 4 in terms of f of x equals 2 to the power of x. Well, what we have here is the function in standard form looks like this. Okay, we have f of x equals 2 to the power of x, but as far as transformations, we have a possibility of a out front, and then we have 2 to the power of x minus h, and then we have finally plus k. So these values a, h, and k represent transformations of the original function f of x equals 2 to the power of x. Well, here we have in the function g of x equals 2 to the power of x minus 3. Okay, they put that in parentheses here. And we have minus 4. And minus 4 on the outside here. What we have here is h is equal to 3. So there it is. So we have h is equal to 3, which means that we're going to, this minus 3 is going to shift 3 units to the right. And we have k is equal to negative 4, which means that the parent function is going to come down by 4 units. So f of x, we'll make a conclusion statement, f of x equals 2, well, let me start out calling it g of x. G of x is f of x equals 2 to the power of x translated three units to the right and 4 units down. And you can test that in your calculator should you doubt that. So that's going to be our answer to problem 9. Problem 10 is very similar to problem 9. I hope this has been helpful to you. Good luck, and thanks for viewing.